WebRTC mode enables Orchid Core VMS to provide good quality, live and recorded video without requiring a plugin. If you do run into video problems, WebRTC mode provides both standard and Chrome WebRTC statistics for troubleshooting. The summary statistics appear at the top of the list. Click on Summary to view those stats. Most of these statistics are self-explanatory, but we'll hit the highlights. The bandwidth available is the amount of available bandwidth between the server and the client as calculated by the web browser. The bytes received represents the amount of data that has been received from the camera via the server. The camera driver, make, and model are all data points provided by the camera. The connection active stat indicates if there is a working connection between the client and the server. When it's true, you have a good connection and should be receiving video. The frame height and frame width statistics represent the resolution that has been selected for the active camera stream. The frame rate output, frame rate received, and frame rate decoded provide a way to evaluate how the video is being transported. The frames decoded statistic indicates the number of frames that the client has decoded in the player's current session on the stage. The ICE connection stat indicates the state of the ICE connection. ICE stands for Interactive Connectivity Establishment, which is a method used to identify the most direct communication means available. When this stat reads connected, ICE has found a viable candidate pair for transporting video. If the ICE connection stat is failed, no viable candidate pairs were found. The jitter statistic represents the amount of jitter in the video. Jitter occurs when packets of video are received out of order. As jitter increases, video quality decreases. Packets received and packets lost provide information about the video transport from the server to the client. If packets lost continues to increase, video quality will decrease and may make it impossible to display video. The uptime statistic represents the amount of time the player has been on the stage in the current session. Under the summary stats, the system displays the Chrome WebRTC statistics that provide details on the connection candidates that the system may use to transport video. You can expand any of these entries to view more details. You will see multiple entries in this list that are called Local Candidate and Remote Candidate. Each of these are potential but unused points of contact for communication and video transport. Local candidates represent the client side, and remote candidates represent the server side. But why do we see multiple options from each side, you might ask? Because there are multiple candidate types, all of which may be available for both the local candidate and the remote candidate. Local candidate types, also known as host candidates, are those addresses, an IP address and a port, that are found locally on the device itself. This includes the device's internal IP address, its internal VPN address, and an address for each network card, if the device has more than one. Stun candidate types, also known as server reflexive candidates, are those addresses that are detected by a remote stun server. If the stun server resides on the public internet, like stun.ipconfigure.com, it will identify all of the public addresses that are available on the network the device is on. PR Flex candidate types, also known as peer reflexive candidates, won't be seen very often. These represent the address as viewed from the connection device. This would occur if the device, either the server or the client, received a connection request from the other device, and the address information was slightly different than the local candidate. Let's focus on the chosen candidate pair. This is the candidate pair that the stun server has determined is the most suitable. You can spot this one easily because it is listed in bold font. Click on this entry to expand it and view more details regarding the chosen candidates and the status of the media transport. The system will provide the IP address, port, and candidate type for both the local and remote candidate. The bytes sent and received and the packets sent and discarded provide a way to evaluate how the video transport process is going. The active connection statistic, when true, verifies that this connection is being used for media transport. The transport type statistic specifies the Internet protocol that will be used for video transport. This will usually be UDP, which is ideal for voice and video communication. The requests sent and received and the responses sent and received provide a way to evaluate connectivity checks with the stun server. Let's take a look at a few candidate pair examples. In this first example, both the local and remote candidates are the local type. In this case, the client and the Orchid Core VMS server are on the same network. In the next example, both the local and remote candidates are shown using the same IP address, but different ports. This indicates that the client and the server are actually the same device, meaning we're monitoring our video on the Orchid Core VMS server itself. In our third example, both local and remote candidates are the stun type. It appears that both devices are behind firewalls, so a stun server is being used to acquire candidates using public IP addresses for both. Our last example depicts a situation in which the system cannot find any viable candidate pairs. When this happens, the summary statistics will show that the ICE connection has failed. You will also notice that none of the candidate pairs are shown in bold font. On the stage, the player will display an error message, indicating that the system was unable to open a connection for the camera stream.